All right, welcome to your lesson. It is chapter 9, lesson 1 from your textbook, and we are talking about linear functions today. And this will really prep you up well for Algebra 1 because this is going to be something that you'll work on a lot next year. So first things first, we want to talk about some important vocabulary. The first word I want to discuss with you is function. Function. So a function is basically a scenario where you put something in and you get something else out. So I like to think of this situation as like a machine. And I'm going to use a non-math example to explain how I like to think of a function. So I love coffee, and every morning I put my coffee grounds in the coffee maker. So I put in coffee grounds. Now, thank goodness coffee grounds don't come out. That would be quite a yucky cup of coffee. But after I put in coffee grounds, I have fresh, smooth coffee that comes out of my coffee maker. So this is a very simplistic way of thinking of a function, but I want us to be thinking of a function in the way that you put something in and you get something else out. So again, in this example, I would put coffee grounds in, I get coffee out. So my function is I put coffee grounds in, I get coffee out. Now in math, we can think of functions where we put an x in and we get a y out. So if I'm told something like y equals x plus 2, that means that all of my x's, I will add 2 to that and then I'll get my y. So pretend that x equals 1. So if I were to put a 1 in for my x, just like I put my coffee grounds into my coffee maker, I would get out 1 plus 2, or I would get out a 3. So again, my function is y equals x plus 2. I put a 1 in for my x, and I get a 3 out. That is a function. I put something in, I get something else out. Now, lastly, we need to discuss two words that are called domain and range. And typically, I would teach you guys a song with this, but since we can't sing it together, I'll just sing it for you. And this will help you memorize what domain and range are. So we say domain is the x, range is the y, domain is the x, and range is the y. Okay. I feel kind of silly singing that to an empty room, but that's okay. So domain is the x, range is the y. So I want to take a look with you at a few examples and look at our x's and y's and check to see if these are functions. So before we check to see if these are functions, we'll talk about how we check that, and then I also want to kind of break down what these actually mean right here, these little tables. So my domain is my x's, and my range are my y's. So my first x, my first domain, is paired with a 1. So that's going to be the point 2, 1. My second point is going to be 4, 3. My third point is 5, 4. And my last point is 9, 7. Okay. Now, these are my points, and these points all together make a relation. A relation is a set of points. So to determine if something is a function, we want to look at our domain. We just want to check our domain. So I have a 2, 4, 5, and a 9 in my domain. So all of my x's are different. So this is a function, okay? So this is a function. All of my x's are different. So all of my x's have their own y's. And we'll get more in depth with this later on. So let's take a look at another one. So my domain is on the left. Those are my x's. My range are on the right. Those are my y's. So my first point is 2, 1. Now this is a little tricky. My 2 also goes to a 3, so that is a way of writing a second point of 2, 3. My third point is 5, 4. And my last point is 9, 7. Now remember, to check if something is a function, we want to look at our x's. Now, in this case, I have two x's that are the same, so I need to do a double take. I have two x's that both are the same number. They are both 2's. So I need to check to make sure that these 2's go to the same range. So here I have a 2 that goes to a 1. Here I have a 2 that goes to a 3. So because my 2's, my x's, go to two different y's, this is not a function. Okay, so I have two of the same x, two of the same domain, and they go to different y's. Now let me throw a quick scenario at you. Say, and I'm just making this up, say I had 2, 1, 4, 5, and again 2, 1. So if I were checking to see if this was a function, again, I would notice that I have two of the same number. I have two 2's, but in this case, my 2 goes to a 1, and then when my 2 is seen again, it goes to the same number. So this would be a function because the same x is going to the same y. So if I have a repeat x, the same x that repeats, it has to go to the same y to be a function. Let's try a couple more. Okay, so below I have a table. We are looking at example B together. And again, I want to draw my attention to the domain. I'm not worried about what the y's are doing. I really care about the domain when I'm checking to see if something is a function. So my domain are the x's, and the range are the y's. Now when I'm going to circle my domain just so you guys are clear that those are the x's. So I have a 4, a 7, a 6, a 3, a 5, and a 2. So all of my domain are different. All of my x's are different. So this is a function. Now, if I were thinking of these as a set of points on a graph, this would be 4, 6, 7, 10, 6, 11, and so on. Let's take a look at a couple more examples. For 1a, I have a set of points written out. And again, remember that your domain are the x's, your ranges are the y's. So I'm going to write out my domain. I have 5, 6, 7, and 8. So our domain always come first. Those are the x's. So 5, 6, 7, and 8. Now my range are the y's, 1, 3, 5, 0. To check if this is a function, I just want to do a simple test. Look at all of my x's. All of my x's or my domain are different, so this is a function. Here I have a table. Again, this represents a relation. All of my x's have their own y's. So I have 1, 7. So my domain is 1. My range is 7. I've got 6, 6, 3, 2, 1, 8, 5, 2, and 2, 1. Now, when I look at my domain, I have two domains that repeat. I have a domain that is 1, and then 1 appears again. Now, for it to be a function, my x's that are the same must go to the same y. So here my x goes to a 7, or we say that's mapped to a 7, and here my x, which is the same x, goes to an 8. So this is not a function, okay? So my same domain go to two different range. Now pretend that in this example, this was rewritten and this 8 was actually a 7. So pretend that that 8 was a 7, okay? So if that 8 was a 7, this would be considered a function because my x goes to a 7, and then my same x, which is a 1, also goes to a 7. So in that case, if the same x went to the same y, then that would be a function. Okay. So one of our last examples for today, we have a relation which remember, a relation is a set of points. But instead of having the points actually written out, we have the points on a graph. So this is something that is called the vertical line test, and you can use this to check to see if something is a function. So I like to just draw a lot of vertical lines, and vertical means that you go straight up and down. You do not go side to side or across. Now, if your points from your function touch your vertical lines in more than one spot at the same time, then you don't have a function. So let me show you what I mean by this. These are not perfect vertical lines, but I did my best. Here my vertical line touches the point 2, 3. Okay. Here, this is a bad vertical line, but if it was a completely straight line, my vertical line would also go through 2, 1, 2, 1. Now, because you can see that I have the same x, the same x is 2, that goes with 2 different y's, this would not be a function. So here my 2 goes with a 3, here my 2 goes with a 1. So this is not a function. Let me show you one more reason this is not a function. With these 2 points right here, I have 1 point that goes through 1, 2, 3, 4, 5, 6,